Hello and welcome to our trigonometry practice midterm exam. We've got 20 questions to get through. Let's get started. Question number 1. They want us to convert the angle in degrees to radians and express the answer as a multiple of pi. So in order to convert a degree to radian, first thing we want to do is multiply by pi over 180. And going straight across, multiplying, that's going to give us 300 pi over 180. And then we want to reduce that. So the easiest way to reduce is with our calculator. We're going to have 300 over 180. That fraction reduces to 5/3. And so our final answer would be 5 pi over 3. Next, question number 2. We want to convert the angle in radians to degrees. So to convert from radians to degrees, you multiply by 180 over pi. Here we can see that our pi's are going to cancel, and then we multiply straight across. That's going to be negative 19 times 180 all over 4. Again, the easiest way to simplify that is with the calculator. Using our fraction button, 19 times 180 divided by 4, 855. So in degrees, that's going to be negative 855 degrees. Next problem, find the arc length S of a circle of radius 5 subtended by the central angle 240 degrees. So here to find the arc length, we're going to need our formula for arc length, S equals R times theta. Since they asked me to find the arc length, we're going to plug in for R and theta. So our radius is 5, and our angle must be in radians. So the first thing I'm going to need to do is convert 240 degrees to radians. So we're going to multiply by pi over 180. Again, I'm going to bring up my handy dandy calculator to do that. That's going to be 240 over 180, which will give us 4/3, simplifying our angle to 4 pi over 3, and then plugging that in for theta. And notice it doesn't say to round, so I'm going to give the exact value and the approximate value just in case you need them both. Multiplying across here, we're going to have 20 pi over 3. And if I round that to 2 decimal places, as a fraction, 20 pi over 3 is approximately 20.94. Now the units for arc length are always the same as the units for the radius. So that's going to be 20.94 meters or 20 pi over 3 meters exactly. Next, problem number 4. The variable theta is a real number where P, here they've given us an ordered pair, is a point. Notice it does say on the unit circle. And remember that means that we have a radius of 1. They want us to find tangent of theta, which is y over x. And in this case, y is the square root of 5 over 3. And that needs to be divided by x, which is negative 2/3. Now, when we have division with fractions, that's when we KCF. We're going to keep, change, flip. 3's are going to cancel, giving us a value for tangent, square root of 5 over 2, and that is the simplified final answer. Next, number 5, find the exact value of the expression 2 sine pi over 3 minus 3 tangent of pi over 6. Now to do this without a calculator, we're going to call in the unit circle, and we need to know what is the y coordinate at pi over 3. All right, so with our unit circle in play, sine of pi over 3, we're going to go to pi over 3. Sine is y. That is square root of 3 over 2. So that's going to be 2 times square root of 3 over 2 minus 3 times tangent at pi over 6. At pi over 6, remember tangent is y divided by x. So that's going to be 3 times y divided by x. And then we're going to need to simplify. Here the 2's will cancel, leaving a square root of 3. Minus 3 times, doing the KCF again, is going to give us 1/2 times 2 over square root of 3. And the 2's are going to cancel, giving us square root of 3 minus 3 over square root of 3. And then if we rationalize the fraction, that'll be 3 square root of 3 over 3, where the 3's will cancel, giving us square root of 3 minus square root of 3, which is 0. Now, I would like to show you how to use the Casio to check your answer. Even though you're supposed to show your work, we can use the Casio to check. So we're in radian mode. I'm simply going to type this in just the way it was given. 2 sine pi over 3 minus 3 tangent of pi over 6. And if we did the math right, we should get 0, and the answer is verified. Number 6, use a calculator to find the approximate value of the expression. We need to round to 2 decimal places. So, tangent of pi over 5. First thing we need to realize is that we are in radians. This angle is a radian angle, so we need to be in radian mode, which we are. And then we're going to go tangent of pi over 5 equals, and to 2 decimal places would be 0.73. 0.73 approximately. Next, number 7, find the exact value of the following trigonometric functions of theta, and they give me an ordered pair, but they do not specify that it is on the unit circle. So the first thing I want to find is the radius, and then if the radius is 1, we know sine is y, cosine is x. If the radius is not 1, then sine is y over r, and cosine is x over r. So we're going to use the Pythagorean theorem to find the radius and see if it is 1 or not. Doing a little plug and play. -5 squared plus -7 squared equals r squared. That's going to be 25 plus 49, which is 74. And taking the square root of both sides, we get that the radius is the square root of 74, which is not 1. Now, we want to check and see if that is in simplest radical form. So I'm going to type in the square root of 74. And since it gives me back the square root of 74, we know that it cannot be simplified. Now, that also means that we're going to have to use these formulas for sine and cosine, y over r and x over r. So y was -7. Sine is -7 over square root of 74. But we're going to need to rationalize that. So square root of 74 copies to the top. The square root symbol in the bottom disappears, and that is now rationalized. Cosine is x over r. X is -5 over the square root of 74. Again, we need to rationalize. So copy the square root to the top, erase the square root symbol in the bottom, and there are our exact answers rationalized. Next, number 8, name the quadrant in which the angle lies. So to do this problem, we're going to have to remember that all students take calculus. Just remember that is a very positive statement. In other words, that indicates which trig functions are positive in the four quadrants. All of the trig functions are positive in the first quadrant. Sine, tangent, and cosine are positive in their respective quadrants. Now look at what we've got. We've got tangent is less than 0. We know that negative things are less than 0, so they're telling me tangent is negative. And sine is also less than 0, so they're telling me sine is negative, which automatically rules out quadrant 1 because all of the trig functions are positive in quadrant 1. And the only trig function not mentioned here is cosine. So that has to be quadrant 4 because only cosine is positive, sine and tangent would be negative, and that's how you answer that question. Number 9, given the following information, find the exact value of the indicated trigonometric functions. Here they give us tangent is negative 1/2. We know that tangent is y over x. And they also give me that our angle is in quadrant 2. And we know if your angle is in quadrant 2, that the ordered pair, in other words, the x comma y in quadrant 2, is going to have a negative x and a positive y. And so that tells me that the 2 here gets the negative because it's going to be the x value, and the y is 1. We need to find sine and cosine. So sine is y over r, cosine is x over r. We're going to need to find r. Again, using our Pythagorean theorem, x squared plus y squared equals r squared. We know that x is negative 2 squared, y is 1 squared. That's going to give us 4 plus 1, which is 5. And taking the square root of both sides gives us a radius of square root of 5. And now we can find our trig functions. So again, back up here, we know y is 1. That's going to be 1 over square root of 5. But that needs to be rationalized, giving us square root of 5 over 5. X is negative 2. Negative 2 over square root of 5, again, needs to be rationalized. That is negative 2 square root of 5 over 5. And that is done. Next, problem 10. They want us to find the amplitude, period, and the phase shift of the function. So what I recommend you do in this case is label your pieces going across. A is negative 2. B is 3. C is pi over 2. And then we can find the amplitude first. We know that the amplitude is the absolute value of A. Absolute value of negative 2 is 2. The period, which we use a capital T to represent period, is 2 pi over B for the cosine function. And B is 3, so that'll give us 2 pi over 3 for our period. And the phase shift is negative C over B. So C is pi over 2. That's going to be negative pi over 2 all over 3, which we can make that a fraction. 3 over 1 and KCF. This is when we keep, change, flip. So that's negative pi over 2 times 1 over 3, giving us negative pi over 6 for our phase shift, and that is done. Next, number 11, we want to graph two periods of the following function, then use the graph to determine the domain and range. So here we have a cosine function. We can see that the amplitude is going to be 4 because it is the absolute value of the coefficient of the trig function. The period is 2 pi over b. B is 3 in this case. And the phase shift is non-existent because we have no value for C. So now that we know the amplitude, period, and the phase shift, we can go through our graphing technique. Cosine starts at the number in front. So I'm going to say that this is 4 right here. And then if we had a phase shift, we would deal with that, shifting the starting point, which we don't have a phase shift. So our next step would be to determine the wavelength. Well, that's the period. And I'm going to call this right here 2 pi over 3. Now, if you start up at 4, you should finish up at 4 because you always finish where you start. And we know from start to finish we need 4 equal spaces. So I'm going to cut that in half. And then half the halves. The reason you need 4 spaces is because the hash marks are where your dots go. Starting up at 4, we're going to go down, down, and then up, up, and connect the dots. And we have one complete cycle, one period. It says we need at least 2 periods. So we're going to copy and paste that wave and go another period here. Down, down, up, and up. And connect the dots. All right, so let's figure out what this last hash mark should be. If this much is 2 pi over 3, then another wavelength would be another 2 pi over 3. 2 pi and 2 pi is 4 pi over 3. So that would end up at 4 pi over 3. We can see that we go up 4 as well as down 4. And to determine the domain, well, that's super easy because the domain of every sinusoidal function is always all real numbers. That is minus infinity to infinity. And the range, which are the values that y can be, we can see that y never gets below -4, but it also never gets above 4. So the range is everything from -4 to 4, including -4 and 4. And that takes care of that problem. Next, number 12. Find the amplitude, period, and the phase shift. Graph at least 2 periods. Give the domain and range. All right, here we go. Amplitude, absolute value of the lead coefficient, which is going to be 6. The period is 2 pi over b, but b is a half this time. So what we're going to do is our KCF. We're going to keep the 2 pi, change to multiplication, and flip the fraction, giving us 4 pi as our wavelength. And our phase shift is -c over b. C is already negative, so that's going to make it +c over, I'm going to do the KCF on the fly here. So c divided by b would be multiplied by the reciprocal, giving us 2 pi over 3 for our phase shift. Once you know the amplitude, period, and the phase shift, you can sketch the graph. First step, we know that sine starts at the origin, so I'm going to lay down my first point, and then we immediately have to shift it because the second thing you have to deal with is the phase shift. So I'm going to have to shift 2 pi over 3. Here's what I'm going to do. I'm going to say that each space is a pi over 3. And so that means that my starting point is going to have to shift to here because that would be 2/3 of a pi, 2 pi over 3s. So that takes care of the phase shift. Then we need the wavelength, which is 4 pi. Remember, we need 4 equal spaces. And so to figure out, how much we're going to go over for the spaces, hang with me. The period is 4 pi. So we want to divide that by 4 to figure out what our spaces are. 4 pi divided by 4 is pi. Now remember I said that each one of these hash marks is a third of a pi. So would you agree that 3/3 is a pi? So every time I go 3 spaces on my grid, I've gone a distance of pi. Okay, so we're starting here. I'm going to go 3 spaces, and that will be a pi. There's 1 pi, 2 pi, 3 pi, 4 pi. You with me? That lays out my wavelength. I can go ahead and put a dot here because it's going to finish where it starts. And if I want to figure out what that is labeled, I can count by thirds of a pi. 1/3, 2/3, 3/3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That would be 14 pi over 3 at the end point. And now I can lay out my points and connect the dots. The original 6 was positive. That means we're going to be up at 6 at the first hash mark, and then return to the axis, and then down at -6, and then return to the axis, and then connect the dots. And we get our nice smooth sine wave. We need 2 periods. So we're going to copy and paste. Here we go. Remember, every 3 spaces is a pi. 1 pi, 2 pi, 3 pi, 4 pi. We're going to finish 1 hash mark off the edge of the graph. Here we go. Up, down, down, and up. And connect the dots. Okay? So if this is 14 pi over 3, we can keep counting pi over 3s to figure out what the endpoint is. Okay, here we go. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Pi over 3. And 26 doesn't divide by 3. So we would just leave that 26 pi over 3 if you need to label it. Here, this is up at 6. This is -6. The domain, again, is all real numbers because every sine and cosine wave has an unrestricted domain. But the range is from bottom to top, from -6 to 6 in this problem. Next, question 13. We need to graph 2 periods of the following function and determine its period. Use the graph to determine the domain and range. Now this time we have tangent, and the period formula for tangent is pi over b. B in this case is 2, and so our period is going to be pi over 2 for this graph. And that really is the only thing we need to figure out in order to get the graph here. So we have a process for graphing tangent. And the first thing is to realize that our consecutive asymptotes for tangent are from -pi over 2 to theta, which in this case is 2x, to pi over 2. We need to divide everybody by 2 in order to get the x by itself, which gives us -pi over 4 to pi over 4 as consecutive asymptotes. And so what I'm going to do is I'm going to say 3 spaces is pi over 4. I'm just calling it that. So I'm going to have an asymptote at -pi over 4, and then I'm going to have another asymptote at pi over 4. Once you've laid out your consecutive asymptotes, the next step is to put an x-intercept right in the middle. And then at the first and third quarters, we're going to be at -a and a respectively. does that mean? That means that we're going to be at -4 at this first hash mark, which is actually right here in the middle. But then we're going to be at +4 at the third hash mark. And you should be able to see a nice smooth curve coming through approaching the asymptotes. Now that's how you generate one period of the tangent function. To get another one, we're going to have to go over another 6 spaces. And at the first and third quarters, again, we're at -4 and 4 respectively. And can you see basically all we did is copy and paste that first piece. So if this is at pi/4, this would be 2 pi/4. This would be 3 pi/4. Now it's important to note the spacing of the asymptotes because that's going to be needed to determine the domain. Everywhere there's an asymptote is a value that x can't be. And so here we can see our domain is going to be the set of all x's such that x cannot be a multiple of pi/4. So we say that is pi/4 times k, and not just any multiple. Notice it's 1 and then it skips to 3. So it's odd multiples of pi/4. So k is an odd integer. Let me pull that over some. K is an odd integer. The domain is the set of all x such that x cannot be any odd multiple of pi/4. That's basically what we have written here. And that is where the asymptotes are. And again, the range is super easy for tangent and cotangent. It's all real numbers because the graph goes down forever and it goes up forever with no breaks in the graph. Next, number 14, we need to graph two periods of the following function and determine its period. Use the graph to determine the domain and range of the function. All right, well, to find the period of secant or cosecant, that is the same as the period formula for sine and cosine. That is 2 pi over b. B in this case is a half. So 2 pi over a half is the same as 2 pi times the reciprocal, and that's going to give us 4 pi. So our wavelength, our period, is 4 pi, although the cosecant and secant don't make a wave. And then what we're going to do is we're going to follow the steps for graphing sine. Sine is related to cosecant. If we had secant, then we would graph as we were graphing a cosine. So here we go. Sine starts at the origin. So I'm going to put a dot at the origin. If I had a phase shift, I would scoot that point over, but we don't have a phase shift, mainly because we don't have a value for C. And then we're going to talk about the wavelength. Well, the wavelength is 4 pi. So what I'm going to do is I'm going to say every 2 spaces is a pi. How about that? So there's 1, 2, 3, and 4. And so this would be 4 pi here. And then we're going to, again, lay out our points as if we were doing a sine wave. We're going to go up first because our initial 3 was positive, and then down to -3 and back up. And then this is where the technique changes from sine to cosecant. Now, every x-intercept becomes an asymptote. And the points at the hilltop and the valley become our humps and bumps, or at least that's what I call them, our humps and bumps. And that gets 1 period. we need another period. So we're going to go another 4 spaces. Remember, every 2 spaces is a space to me. We're going to end here. We're going to have asymptotes. And we're going to go up, down, down, and up. And we've got another hump and another bump. And so there's 2 periods, 2 wavelengths. And it might be nice to know some of these values here. Okay, so we said that every 2 spaces is a pi. So that's 1 pi, 2 pi. This would be 3 pi and 4 pi, which is hard to see now. This is 4 pi. And then 5. This would be 6. Let's put him up here. 6, 7, and 8 pi. All of those laid out now. Now, what do we need? We need the domain. Remember that everywhere there's an asymptote, that is a value that x can't be. So in order to write that correctly using set notation, we're going to say the domain is the set of all x's such that x cannot be. And where are our asymptotes? Well, we have an asymptote at 0, and then at 2 pi, 4 pi, 6 pi, 8. It looks like even multiples of pi. So we're going to say pi times k, where k is an even integer. Okay, that's going to be our domain. It's the set of all x's such that x cannot be an even multiple of pi. And that accounts for 0, 2, 4, 6, 8, so on and so forth. That is our domain. Now the range is a little bit more exciting than the previous problem. Remember, tangent and cotangent, that's just all real numbers. But here, if you look, if I were to use a colored pencil, you're going to see there's a whole section in here where the graph doesn't exist. So the range goes to minus infinity, but doesn't get any higher than -3. And then it picks up again at 3 and goes to infinity. So how do we write that using interval notation? Well, we say that the range is everything from -infinity up to -3. We're going to use a bracket because it actually does touch at -3. And then the union symbol because we have a gap in the graph. And then we pick up again at 3 and go to infinity. And that is the range in interval notation for this particular graph. Next, number 15, find the exact value of the following expression. Notice it says do not use a calculator. What we know about inverse trig functions is that they always produce an angle. Inverse trig functions equal to an angle. And then if I bring the inverse trig function to the other side, it's going to turn it back into regular cosine. So you see, if I bring it over, it makes it just cosine again. That'll be cosine of theta is negative square root of 3 over 2. So now we're going to go to the unit circle and find an x coordinate that equals negative square root of 3 over 2. And whatever angle that occurs at, whatever ordered pair has an x coordinate of negative square root of 3 over 2, that's going to be my answer. Okay, so now that we've got our unit circle up here, looking for an x coordinate of negative square root of 3 over 2, that occurs at 5 pi over 6, which is also 150. But I want you to notice that there is also an x coordinate of negative square root of 3 over 2 at 7 pi over 6. So if you're wondering which one of these angles is correct, well, it depends on the values that inverse cosine produces. It's like the range of values that are acceptable answers for the inverse trig functions. And we know that the inverse cosine produces angles from 0 to pi. You have to look for an ordered pair in this range. And since 7 pi over 6 is not in that range, we know the answer is 5 pi over 6. Now notice it says do not use a calculator. I'm going to use a calculator just to check my answer. I'm going to need to see this scratch work. Really, showing that cosine is x at 5 pi over 6. But to check this, we can say inverse cosine of negative square root of 3 over 2. And on the Casio, it will actually give you that answer straight out. And so that verifies that what we did with the unit circle is correct. Next, number 16, find the exact value of the following expression. Again, do not use a calculator. And I've got my unit circle over here in case I need to reference it. What we have here is the inverse sine of the sine of 4 pi over 7. Notice that 4 pi over 7 is not a unit circle angle. So I'm simply going to be using my unit circle to draw on for reference. It's not going to help me as far as really getting the answer. But the first thing I would like to remind you of is that inverse trig functions produce an angle. And if I bring that to the other side, that's going to say sine of 4 pi over 7 equals sine of theta. And you may be thinking, well, the only way that these can be equal is if the angles are the same. And so theta would be 4 pi over 7 if this radian is within the acceptable range that an inverse sine can produce. Now, inverse sine can only produce angles from negative pi over 2 to pi over 2. So our angle has to be within this range of values for it to be a correct answer. 4 pi over 7 is not within this range, okay? And I can prove it because pi over 2 at 90 degrees, if I convert that to an equivalent fraction so that I can compare these, what I would want to do is multiply this denominator by 7 and this denominator by 2. And here we can see that 8 pi over 14, over here we have 7 pi over 14, and this is bigger, which means that 4/7 is bigger than pi over 2, which would throw it off into quadrant 2, which is not in the range of acceptable values for an inverse sine function. Okay, so all of that to say that 4 pi over 7 is not the right answer. All right, so how do we get our correct equivalent answer? Well, we know that this is 4/7 right here, okay? So to go from 0 to here would take 4 pi over 7. I want to know how much would it take to get on to pi. Well, if I'm at 4/7, would you agree that I would have to go 3 more sevenths to get to pi? Add those. 4 pi over 7 plus 3 pi over 7 is 7 pi over 7, which is pi. And so this acute angle here is 3 pi over 7. And so that tells me that either this or the negative of that is the correct answer, depending on which quadrant produces the same result. So, what is sine in the second quadrant? Does sine produce negative answers or positive answers in quadrant 2? Well, from our all students take calculus phrase, we know that sine in the second is positive, and also sine in the first quadrant is positive. So that means that we need a quadrant 1 angle, not a quadrant 4 angle. Remember I said that it's either 3 pi over 7 or the negative of that? If it was negative, that would throw us into quadrant 4, and the answer for sine would be negative. But we know that our angle, this 4 pi over 7, is in quadrant 2, and the sine of that would be positive. So our answer is not 4 pi over 7, it's 3 pi over 7. And it's positive because that would be a quadrant 1 angle. And sine in quadrant 1 is positive. Now we can verify that with the calculator. Here we go. We want to do the inverse sine of the sine of 4 pi over 7. And again, with the Casio Class Whiz, that will verify straight out that you do get 3 pi over 7 as the correct answer. But you're going to have to show your work and explain how you got it. Next, number 17. Again, find the exact value of the following expression. Again, it says do not use a calculator. So what we're going to do here is say secant of theta. The inverse tangent of 5 pi over 8, that is my theta. And so I'm going to set up an equation that says theta is the inverse tangent of 5/8. I'm going to bring my inverse tangent to the other side, which tells me that tangent of theta is 5/8. But we know that tangent is y over x. And so that tells me my value for x and y. And now I can find secant of theta, okay? Secant of theta is, well, let's see, secant is the reciprocal of cosine. So if cosine is x over r, this would be r over x. I'm going to need to find r. So using Pythagorean theorem, we know that x squared plus y squared equals r squared. That's going to be 64 plus 25 equals r squared. And if I add 64 and 25, that is 89. Taking the square root gets my radius, and is that simplest radical form? Square root of 89, yes, it will not simplify. So that's going to be square root of 89, and I'm all but done, okay? So the final answer, secant of theta, is r over x. X was 8. And that's done. Next, question 18. We need to solve the equation on the interval from 0 to 2 pi. First step, we need to isolate the trig function, dividing both sides by 16. To get rid of the coefficient of the trig function, 12/16 reduces to 3/4. And then to get rid of the squared, I'm going to take the square root of both sides. The square root of 3/4. I can take the square root of the top and the bottom separately. Oh, and don't forget that we need a plus and a minus. Since we did take the square root of both sides, that's going to be plus or minus square root of 3 over 2. Now, I need all of the angles in the unit circle, right, from 0 to 2 pi, all of the angles that have an x coordinate of positive or negative square root of 3 over 2. All right, so in the unit circle, x coordinate, square root of 3 over 2 or negative square root of 3 over 2. Looks like there's 4 of those. So my answers, my thetas are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that's going to do it for this problem. 19. Solve the equation Give the general formula or formulas representing all solutions, then list the first 6 positive solutions. So here our trig function is already isolated. We want to know for what angles in the unit circle have a y-coordinate of negative square root of 3 over 2. Okay, looking for negative square root of 3 over 2 in the y-coordinate. Yeah, it looks like there's 2 of those. But now remember, our angle is not just theta, our angle is 2 theta. So we're going to have to say this time 2 theta can be 4 pi over 3, or the answer could be 5 pi over 3. Okay, but not just that. Remember, if you go to here, you've got an answer. But then if I make a full circle and return here, it's another answer. So what is a full circle? Well, it's 2 pi. So this is an answer plus 2 pi k, where k is an integer. That would represent all of the solutions. That's how you write the general formula. It's 4 pi over 3 plus as many times as you want to go around the circle and return to 4 pi over 3, where k is an integer. It's an element of the integers, and that's one way to write the integers. The same thing happens with the 5 pi over 3. Once you get there, if you keep going around, no matter how many times you go around the circle, no matter how many times you increment by 2 pi, you're going to get an answer. K is an element of the integers. Okay, so now we need to actually find out what theta is, and that means that we're going to need to divide through by 2. Divide through by 2, all the way through. And so my formulas for theta, what is pi over 3 divided by 2? Well, that is 2 pi over 3. And if you're wondering how I got that, well, I did 4 pi over 3 divided by 2. And that tells me that that's going to be 2 pi over 3 plus, and then these 2's cancel, plus pi k, where k is an integer, and theta is 5 pi over 3 divided by 2 would be 5 pi over 6. And again, let's prove that with the calculator. Five pi over 3 divided by 2, 5 pi over 6 is our second angle. So this is our second formula. Again, those 2's cancel, giving us pi k, where k is an integer. These are the general formulas. And then what did it say? It said, then give the first 6 positive solutions. So to generate the first 6 positive solutions, we're going to need to start with k equals 0 and substitute for k in both of these formulas 0. And then we're simply going to increment k until we get our 6 answers we need. So 0, 1, and I think 2 will be the last time through. So if k is 0, 0 times anything is 0, which will eliminate these pieces. And so my first 2 angles, my first 2 solutions would be 2 pi over 3 and 5 pi over 6. And then that takes care of k is 0. And then next, k increments to 1. Pi times 1 is pi. And so our next 2 angles would be 2 pi over 3 plus pi 5 pi over 6 plus pi. And again, we can figure those out a lot easier on the calculator. So 2 pi over 3 plus pi gives us 5 pi over 3. And we also need to do 5 pi over 6 plus pi, giving us 11 pi over 6. And that takes care of the values for when k is 1, and then increment k to 2, which means we're going to replace these k's now with a 2, which means we're going to do the exact same button pushes, except instead of pi, now it's going to be 2 pi. So our first angle there is going to be 8 pi over 3. And incrementing the 5 pi over 6 plus 2 pi, 17 pi over 6. And for the last problem, problem number 20 on our practice midterm exam, use a calculator to solve the equation on the interval from 0 to 2 pi. We have sine theta is 0.92. So the first thing I want to do is I want to isolate theta. I'm going to bring the sine to the other side, which makes it inverse sine of 0.92. And then I'm going to use my calculator to get my initial angle. Now, if you're wondering, do I need to give the answers in radians or degrees? This right here is how you tell. If it said from 0 to 360, then you would want your answers in degrees. But since they use a radian, you want your answers in radians. And notice it doesn't say where to round to. So unless we get nice values, we're going to have to round. I'm going to go ahead and assume round to the nearest hundredth. Since the decimal they gave me is 2 places, I'm going to round my answers to 2 places. So here we go. Inverse sine of 0.92 in radian mode is going to give me 1.17 rounded. Now that is my first angle, okay? That is a positive answer, and so is this guy. This is a positive value. Now let's go to the coordinate system. We know that sine in the first quadrant is positive, and this angle, this 1.17 radians, is a quadrant 1 angle. Now I know that because this is pi over 2, and if we do pi divided by 2 as a decimal, that's 1.57. So this is approximately 1.57. 1.17 is less than that, so that puts that angle in quadrant 1. Remember I said that this number is positive. We know that sine is also positive in the second quadrant. And so this means that I'm going to have a reference angle of 1.17 in the second quadrant that will produce the same y value. And so now I have to figure out, well, what is this angle theta here? Well, that's not bad because I know that this is pi. Pi is 3.14. And if I subtract this amount, I'll get the angle I need. So I need to minus 1.17 from 3.14. And as a decimal, 1.97 is the other answer. Okay, now what we can do again is we can use the calculator to check our answers. Because if I plug these angles into the sine function, I should get an answer close to 0.92. Okay, so if I do sine of 1.17, as long as I'm in radian mode, it should give me a decimal value approximately 0.92. If this decimal's not 0.92 or really close, then my angle is wrong. And we can back up and check that. We need to check also 1.97. Again, if that is correct, it'll round to approximately 0.92. And so we verified that these are correct answers, at least to the nearest hundredth. And that's going to do it for this practice exam. So if you have any questions about any problem I've covered in this video, please feel free to leave those in the comments below, or you can text me. And thanks for watching.